What happens at the end of time, the heat death and the fate of the universe, the clock that never stops. Right now, everything feels stable. The sun rises and sets. The stars continue to shine in the night sky. Galaxies spin, planets orbit, and life on Earth moves forward, seemingly untouched by the vast forces governing the cosmos. But this stability is an illusion. The universe is not eternal. It is slowly, inevitably dying. One day everything will end. Not just the stars, not just the galaxies, but time itself. The question is how? For centuries, humans have speculated about the fate of the universe. Will it collapse in a fiery implosion? Will it tear itself apart? Or will it simply fade away, cold and lifeless, until nothing remains? Today, we are going to explore the final chapter of the cosmos, the moment when time itself may come to an end. And the answer might be more terrifying than anything you've ever imagined. The expanding universe, a clock, running out of energy. To understand how the universe will end, we need to start with how it began. The universe as we know it was born in the Big Bang, an event that took place 13.8 billion years ago. From an unimaginably hot and dense singularity, space and time burst into existence, expanding outward at an incredible speed. But here's the key. The universe has never stopped expanding. In the early 20th century, astronomer Edwin Hubble made a shocking discovery. Every galaxy in the universe is moving away from us. The farther away a galaxy is, the faster it is moving. This meant that the universe wasn't static, it was stretching. For a long time, scientists believed that this expansion would eventually slow down. They thought that the force of gravity might pull everything back together, leading to a catastrophic collapse called the Big Crunch, a reversal of the Big Bang where the universe implodes back into a singularity. But then, something unexpected happened. In 1998, observations of distant supernovae revealed that the universe's expansion is not slowing down, it's speeding up. This meant that some mysterious force was working against gravity, pushing the universe apart faster and faster. This force became known as dark energy, and it accounts for nearly 70% of everything in the universe. The discovery of dark energy changed everything. It meant that the universe was not heading toward collapse. It was heading toward an eternal expansion. And this has profound consequences for the fate of time itself. The heat death, when the universe runs out of fuel. If the universe keeps expanding forever, then what happens to everything inside it? Right now, the universe is filled with energy. Stars burn brightly by fusing atoms together, releasing immense amounts of heat and light. Galaxies are full of activity. Supernovae explode, black holes consume matter, and new stars are constantly forming. But this will not last forever. As the universe expands, everything spreads out. Galaxies move farther apart. Stars burn through their fuel. Black holes consume the last remaining matter. Over time, fewer and fewer new stars are born. The ones that exist slowly burn out, one by one, leaving behind only cold, dead remnants. This is the beginning of what physicists call the heat death of the universe. The last stars, the era of red dwarfs. Right now, most of the stars we see in the night sky are massive, bright, and short-lived. They burn through their fuel in just a few million years before exploding into supernovae. But in the distant future, only small, dim stars called red dwarfs will remain. Red dwarfs are much smaller and cooler than our sun, but they are incredibly efficient, burning their hydrogen over trillions of years. This means that while large stars will die off quickly, red dwarfs could continue shining for another 10 trillion years, but even they will eventually fade. And when the last red dwarf finally flickers out, the universe will enter the dark era, the black hole era, when only darkness remains. At this point, the universe will be almost completely dark. All normal stars will have burned out, and the only sources of energy will be black holes. Black holes are the final stage of massive stars. objects so dense that not even light can escape their gravitational pull. They will dominate the cosmos for an unimaginable amount of time, slowly consuming whatever matter is left. But even black holes are not eternal. In 1974, physicist Stephen Hawking discovered that black holes slowly leak energy in the form of Hawking radiation. Over time, this radiation causes them to shrink. For small black holes, this process takes trillions of years. For the most massive black holes in the universe, it could take 10 to the 100th years, a number so large it is beyond human comprehension. But eventually, they will evaporate. One by one, the last black holes in the universe will disappear. And when the final black hole vanishes, the universe will be completely empty. No stars, no planets, no light, no movement, just a vast, dark void stretching endlessly in all directions. And yet, time will still exist. For now. The death of time itself. A slow and silent end. By this stage, the universe has become a cold and infinite abyss, a void stretching beyond the limits of comprehension. With all the black holes evaporated, all the stars extinguished, and all matter broken down into its simplest particles, there is nothing left to change, nothing left to move. The universe has lost its ability to evolve. This is the moment when entropy, the slow, inevitable force that governs the universe, has won. Right now, entropy is what causes things to break down, for order to dissolve into disorder. It's why ice melts, why stars burn out, why structures crumble. Entropy is the arrow of time, always moving forward, never reversing. But what happens when entropy reaches its maximum? When there is no energy left to spread, no structures left to decay? Physicists call this state thermal equilibrium, and in the grand cosmic scale, it means that time itself may cease to function in any meaningful way. Because if time is defined by change, by movement, by the difference between the past and the present, then what happens when there is no difference at all? A universe frozen in time. Imagine a single frame of a film. If the movie is still playing, you can tell that time is moving forward. Events happen. Things change. But if the film stops, if no new frames appear, then the concept of time becomes meaningless. That is the universe at the end of time. No explosions, no collapses, no fiery destruction, just an infinite silent frozen expanse where nothing will ever happen again. You might be wondering, wouldn't this take trillions of years? Yes, and more than that. The number is so large that it transcends human comprehension. We are talking about 10 to the 100th power years, a number called a googol. A number so large that if every atom in the observable universe were writing 1 digit per second, it still wouldn't be enough time to write it all down. And yet, even after this unimaginable stretch of time, the universe would still exist. Cold, dark, and unchanged. A lifeless tomb where the very concept of history ceases to have meaning. At this point, even the most fundamental subatomic particles, the last building blocks of the cosmos, may begin to decay. Protons, the particles that make up atoms, are theoretically unstable. Physicists predict that after a mind-bending 10 to the 34th years, even protons will break down, leaving behind only radiation and scattered electrons drifting through the void. With no atoms, no matter, and no movement, what remains? A universe reduced to its simplest form, an eternal empty nothingness. The final echoes of the universe. And yet, even in this lifeless eternity, the ghost of the universe still lingers. Even though black holes have evaporated, even though galaxies have been erased, something still exists, the afterglow of reality itself. When black holes die, they don't just disappear, they release a final burst of radiation, known as Hawking radiation, into space. This means that even after the last black hole has vanished, a faint glow will still exist. Particles of energy, slowly fading away into the endless dark. These last remnants will drift through the empty cosmos, like the final embers of a once roaring fire, cooling and thinning until they too fade into nothing. At this point, the universe is colder than absolute zero, stretching toward a temperature so low that it is effectively zero, an emptiness that defies human understanding. This is the heat death of the universe in its final, ultimate form. A cosmos that has not only died, but has been erased. A place where existence itself has ended, and with no energy left to spark a new event. With no difference between past, present, or future, time itself stops. A final thought. Is this truly the end? So what does this mean? Is this truly the last chapter of reality? If nothing can change, if time no longer moves forward, does that mean the universe is truly over? Or is there something beyond heat death, something waiting in the silence? Some scientists speculate that quantum fluctuations, random, unpredictable shifts at the smallest scales of reality, could, given enough time, trigger a new Big Bang. Even in an infinite void, tiny fluctuations of energy may still exist. And if one of these fluctuations reaches the right conditions, a new universe could be born. A new explosion of time, space, and energy. A new cycle of reality. This idea is known as the Big Bounce, the possibility that after an eternity of darkness, the universe may somehow restart, creating a new cosmos in place of the old. Alternatively, we may simply be one universe in an infinite multiverse, where other universes are constantly being born, while ours fades into nothing. We may never know, but for now, all we can do is look into the night sky and marvel at the fact that we are alive in one of the rarest moments in cosmic history, one of the few moments where light still exists, where stars still burn, where the universe is still young. One day everything we know will be gone, but for this brief flicker in time, we exist.